In this video, I'm going to talk through the last video I'll do on implications for this section, and that is exploring how to negate an implication. So if you haven't yet, make sure you read through the section. There's two other videos in this little series of videos about implications. In the first video, I introduced this example: if I cross the Mackinac Bridge, then I pay $5. P implies Q, which is a true statement. In the second video, I talked about converse and contrapositive, what those mean in this situation, and I made my points there, how the converse is not always the same as the implication, and the contrapositive is the same. Last thing I'll talk about is how do you negate an implication. So we have now 4 operations on statements, disjunction, conjunction, negation. Oh, sorry, we have 5. So what did I say? I said disjunction. I'll just write the symbol. Disjunction, conjunction, negation. We had XOR, and now we have implication operation between two statements. So these are all operations on statements, and as we're seeing, they behave very differently from one another. So, right, how do we in previous videos and in the book, we saw various laws about these 3 statements, or these 3 operations, and in particular, how they work with each other, De Morgan's laws and distributive laws. How does the if-then combination, the if-then operation, respond to negation? That's what we're investigating here. So if I have the implication P implies Q, what is not P implies Q? That is there any other way for me to write this and understand what the negation of this is? Is there any kind of distributive law for me to bring this negation into P and Q? That's the question here. So in the case of the example, not P implies Q would be that this implication is false. It is not the case that if I cross the Mackinac Bridge, then I pay $5, meaning I could cross the Mackinac Bridge and not pay $5. Right there, it's very natural. You might have some intuition on this. It's very natural. I just said, if this is not true, if it's not the case that if I cross the Mackinac Bridge, then I pay $5, well, what does that mean? That means I could cross the Mackinac Bridge and not pay $5. So that was P and not Q. So it seems like the negation of P implies Q should be equivalent to, maybe I should write this down here, P implies Q, but this is equivalent to, what did I say? P, the hypothesis is satisfied, and the conclusion does not follow. That's what it would mean for an implication to be false, to negate the implication. Now, how can we arrive at this? How can we be sure that this is really true in all scenarios and not just my one example? Well, that's first by proving something pretty interesting, and that is that we can rewrite an implication without using the implication, that this is really made up of these other operations. In particular, P implies Q is equivalent to not P or Q. So how does that make sense? Let's look at our example. Not P or Q. So that would be, I do not pay $5. I do not cross the Mackinac Bridge. P was cross the Mackinac Bridge. I do not cross the Mackinac Bridge. Or I pay $5. So why should this be true? Why does this make sense that this is the same as the fact that there's this toll bridge enforcing this implication? Well, there's 2 cases to think about. Either I cross the Mackinac Bridge or I don't. Now, if I cross the Mackinac Bridge, the fact that this implication is true means I'll have to pay $5. So in that case, I pay $5. Or if I don't cross the Mackinac Bridge, and as we talked about before, if P is false, if the hypothesis isn't satisfied, it doesn't matter what the conclusion is. It doesn't matter if I pay $5 or not. So, but this is saying not P or Q. So those two cases boil down to this. Either I don't pay $5, that was one case. In that case, the implication's true, right? It doesn't matter what the conclusion is. So either I don't pay $5 or I do pay $5 and therefore I would have to, or I pay sorry, I said that bad. Let me rephrase this. Not P or Q. So either I don't pay the $5, or on the other hand, if I want to cross the Mackinac Bridge, that's why I'm messing this up, right? I'm getting my P and Q messed up. So again, P was I crossed the Mackinac Bridge. So not P's, I do not cross the Mackinac Bridge. So sorry, even I can get a little bit turned around with all of this stuff. So let me back up to this. Again, so this would be either I don't cross the Mackinac Bridge or I pay $5. So the two cases again. If I don't cross the Mackinac Bridge, it doesn't matter if I pay the $5 or not. The implication is still true. And if I do cross the Mackinac Bridge, then I'll be forced to pay the $5. So in either case, I have that I've either crossed the Mackinac Bridge or I've paid $5. And those are the only two options, right? Either I cross the Mackinac Bridge or I don't. So in either of those scenarios, I end up with one of these two, right? I get the or statement, not P or Q. And so this is true. This is equivalent to the original implication, equivalent here. And now I get to use, this is cool. Again, my goal is to make sure that this is true, how to negate an implication. It seems like this should be true. So now that I have this other way of writing implication using my other operations, and the fact that I know how the other operations interact with each other means I can do some algebra here. And this is, again, a different kind of algebra than the algebra of real numbers. This is the algebra of statements and open sentences. So not P implies Q. We're going to do some algebra to prove this. Not P implies Q is equivalent to, so I'm going to rewrite P implies Q. That's not P or Q. And this is cool. I get to use De Morgan's law here, right? I have a disjunction between these two statements, not P and Q. So I can use De Morgan's law, not P. So there would be my first statement, right? Not P and not Q. Now, not P, we've seen this in the text. This is double negation. This just gives us P. So this is equivalent to P and not Q. And that proves this equivalence of statements. So sometimes we can prove two statements are equivalent without resorting to a truth table because we've already established how our operations work. All right, that's it for this video. Hopefully you found it helpful. See you next time.